I had a problem with my computer, so I am going to try again with that material you miss after I have audio problems. So I'm going to go to start all over. I'm going to share my course home page. And talk about how you use this one. First thing you need to do is go to module 0 and look at course syllabus here. Course syllabus in here and course calendar. If you go to course calendar, you can see all the dates, what you should be doing during this semester. Everything you need to be doing is listed in the course calendar. We're going to have on the red dates here, September 9th, somewhere around September 9th, we're going to have a test 1 on chapter 1 and 2. Then we're going to have second test on October 2nd, third test on October 23rd, and so on. If you look at the calendar, everything is outlined. Test dates, assignment due dates. So this course is based on module structure. As I shown before, you go back to home page. There are 4 modules, more than 4. Basically, first module 1, module 2, module 3, and module 4 are the important modules. Module 0 is just the introduction to course. Module 1 is dealing with chapter 1 and 2 material. So module 1 is the one we're going to start with. Module 1 has assignments. Chapter 1, quiz 1, chapter 1 and 1, quiz 2, chapter 2. So you need to be doing those 2 before you take the test 1, covering chapter 1 and 2 under module 1. So module 2 is repeated after test 1 on chapter 3 and 4. Module 3 is after chapters 5 and 6. Module 4 after chapters 7 and 8. So you will be, once you go know module 1, you will be familiar with the module structure. So next thing you need to do is, I haven't gone over syllabus. Click on the syllabus here. Syllabus describes everything in detail. Course description, course objectives, learning objective outcomes that you expect, your skills that you need to develop, learning outcomes. And textbook is general chemistry, general organic and biochemistry. We only cover general chemistry part. We cover 8 chapters basically. We plan to cover 8 chapters, but we normally run out of time before end of the semester. So number of chapters covered is dependent on how things goes. The course evaluation is, you should read it carefully. It's based on 4 tests and the final exam. 4 tests counts 50% to your course grade. Final exams contribute 20% to your final grade. There are online Canvas quizzes for chapter 1, 2, 3, 4, 5, 6. There are going to be about 8 quizzes. Average of those quizzes going to be 20% of your grade. Class attendance is monitored, and you will earn 10 points maximum for the grade for class attendance. There's a bonus assignment paper, which details for which is outlined in one of the modules. After module 4, it talks about bonus paper assignment. You can submit the assignment and get 10 extra points to bring up your course average to by maximum of 10 points. The course total is maximum you can earn is 110. 10 is extra 10 is from bonus points. So read the course syllabus carefully and you will understand. If you have any questions, let me know. I will try to answer. I'm going to start the chapter 1 today. I'm going to share with you the chapter 1 slides. I'm going to stop the slide share and go to chapter 1 slides. You can read yourself, okay?
Okay.
Chapter 1 is covering the topics of matter, energy, and measurement. So there's a table of content of chapter 1, learning objectives of chapter 1, and chapter 1 PowerPoint slides. Okay.
I see. Yes, I follow.
So we basically cover chapter 1 and 2. So I have class meeting I recorded last year,
Okay.
2022. That's Zoom class videos. As I go through the class, I will update with new ones too. Okay?
Okay. I see. So I can just go in there and watch the videos, the Zooms for
Yeah.
chapter 1, August 18th, 16, 18, 19. Okay. 1 and 2. I follow.
Okay. The chapter 2 is same same outline.
Okay.
Chapter 2 about the title is about the atom. So then PowerPoint slide. Okay. What I am going to do now is go through chapter 1 little bit. Okay?
Okay.
Just give you a brief idea about the matter, energy, and measurement. Let me share my slide with you. Do you see the slides now?
I'm trying to find those.
That's chapter 1 PowerPoint slides.
Okay, I'm trying to see how to find those slides.
It's in the module 1.
Okay.
The title is Matter and Energy and Measurement. Chapter 1 PowerPoint slide.
Okay, I
That's,
see matter, energy, and measurement. Okay. Wait a minute, maybe I clicked on the wrong thing. I see Introduction to Inorganic Chemistry, Chapter 1, Matter, Energy, Measurement, 1-1, Chemistry and Study, Matter.
okay. Do you see this page somewhere?
Okay, okay, the slides is where I need to be. Chapter 1, PowerPoint slides or
Yeah,
slides handout, Chapter 1. Okay,
PowerPoint
Chapter
slides.
1. Okay. Okay, yeah, I see. I follow. I see exactly what you see. I
Okay,
just had clicked in the wrong thing.
okay. First page of the slide is about how to contact me. My name is Upali Srivoden. You can send me email through the Canvas. My
Okay.
Gremlin email is not working right now. You can send it, use the other email, upali at louisianatech.edu, or call me at 318-278-2272. Okay?
Okay. Now, where's that tech email that I see the
Uh,
one for Gremlin?
since my Gremlin is right now, they have a lot of problems. Sometimes,
Okay. Yeah. I was having an issue trying to get mine because I'm transferring back because I went to Gremlin a few years back and I was trying to get my email situated. I'm gonna have to call the IT people because
yeah,
I can't do it.
same thing happened. I didn't
Oh, I
teach in the
see.
summer. They
Mm-hmm.
just disable.
Yes. Okay. I see your tech one. I see the tech one
Yeah,
behind
take
the Gremlin.
one. They never cancel. I taught at text for long time.
Okay.
I still have the email.
Oh boy.
So,
You're probably gonna have the same issue.
okay, these are the test days. Okay,
Okay.
we talked about that
Mm-hmm.
with reference to calendar. Okay, here is the matter, energy, and measurement title of the chapter 1. So let's talk about. We're going to cover we're going to describe what is chemistry and how it relates to study of matter with respect to chemical and physical changes of matter. So in chemistry, we use scientific method. You probably heard about that.
Yes.
So we're going to talk about that. And reporting measurement with numbers is very common in scientific method and in many sciences. Scientific method start with the observation. Then we measure certain property, preferably with a numerical value. For example, mass, volume, or temperature. They all are numbers. So that's how you make measurements using instruments. Balance, thermometer, pressure gauge to measure pressure, volumetric flasks to measure volume are examples of how you make measurements. Measurements are expressed in number, with a number and a unit. When you measure something, it has a number and a unit. 10 pounds, 15 pounds, 3 kilograms, 4 kilograms, 32 Celsius, or 32 Fahrenheit. So these all have units. So we may be using certain units based on different systems. For example, mass is expressed in pounds and kilograms. So we need to know how to convert kilograms to pounds or backwards. Do you know what is a kilogram? How many pounds are in a kilogram? Kilogram is a smaller quantity than numerical value in pounds. There are 2.2 pounds in a kilogram. Roughly your mass in pounds divided by 2.2. That's how you get your pound mass, body mass in pound get converted to weight in kilograms. Do you understand that? Are you there? Can you hear me?
Yes, sir. I can hear you. I didn't realize my microphone was muted.
Oh yeah.
Sorry.
I was wondering whether I was talking to a wall.
Yes, I muted it so you wouldn't get any background noise.
Okay, that's okay. I want to make sure you are here while I'm talking. So we're going to talk about these topics discussed in the previous slide. And
Okay.
objective is to apply chemistry to study of matter. I outline here the numbers, use of numbers in science,
Okay.
make a measurement, describe states of matter, report measurement using metric units, length, mass, and volume, and also understand the significant figures in a measurement.
Okay.
Then how we convert units to different units, unit conversion. Units conversion factors are used with the multiplication of factor to get the second unit that you are looking for. You should be able to convert temperature units to different scales of unit, for example, Fahrenheit to Celsius, etc. So
Okay.
we also, chapter also deals with energy, study of matter, energy, and measurement with the chapter title. So we are going to look at energy, which is different from matter. Matter is defined as, if you look at here, Matter is defined as anything that has mass and takes up the space. Energy is not matter. Energy could be seen by the actions of matter, reflecting light from an object, shows the location of the object, matter. Sometimes the moving matter has energy, kinetic energy, potential energy, like that. Matter
Okay.
also undergoes chemical change, which involve energy changes. Heat is given out, absorbed. Chemical change is something that matter change completely from different form, one form to another form. For example, if you burn hydrogen and oxygen, you get water. Enormous amount of, large amount of energy is released. That's a chemical reaction.
Okay.
On the other hand, physical change is only a change in states of matter or breaking up of a object without change in the substance. It's a physical change. So we're going to go through examples. Okay.
And find all this.
Okay, which of the following is an example of matter? What do you think?
Example of matter. Let's see. I need to go back to my definition page.
Matter and energy, we are asking. There are two types, matter and energy. Light flame is energy.
And the air you breathe.
Air is matter or not?
Yes.
Air is matter.
Yes.
Sound is energy that pass through a matter. So answer,
matter is the air you breathe.
yeah.
Okay.
The answer is C. Which of the following is a chemical property of gold?
Okay, hold on, let me look at that. My phone is doing crazy stuff. Following is a chemical property of gold.
Color of the gold. Is it a chemical property or physical property? We are asking chemical property.
The color is, you're asking if it's physical or chemical?
Yes.
I would say color would be physical because it's not a chemical, right?
Yeah. Chemical property is when there's reaction take place.
Right.
Color is not produced by a reaction. It is an intrinsic nature of matter. Color is not. Electrical conductivity.
That would be chemical.
Okay, if you have a wire, if you pass electricity, does the wire change after passing electricity?
No, unless it burns.
Yeah, it didn't burn, it just the conduct electricity.
Okay.
Therefore, conduction, electrical conduction is a physical property.
Physical,
Alright?
yeah. Yes. That's physical.
Lack of reactivity.
Lack of reactivity, that would be
It says it doesn't react. Gold
so
doesn't
that
react.
and you said in the chemical it's gotta make a reaction, correct?
Yeah. Gold is inert. It doesn't react. That itself is a chemical property.
Okay.
Some like sodium react with water. So that's highly reactive.
Okay.
Reactivity is associated with chemical property. None, they are all physical properties. What would be the answer?
I would say none, they're all physical, correct?
How about the C? What did he say about it?
Lack of reactivity. So is it C because it's a chemical property of gold, lack of reactivity?
Yeah, less reactivity means
Mm-hmm.
less chemically reactive. So answer is C,
It's C? Okay.
which is not a chemical change. Cutting plywood, you breaking up into pieces, same thing. That's the chemical or physical.
That that would be physical, that's not chemical.
Yes,
Cutting of the plywood is physical.
yeah. Digestion of food.
Which is not a chemical change.
What happens when you eat food?
It breaks down.
It breaks down to different substances, right?
Mm-hmm.
Carbohydrate broke down to glucose, proteins to amino acid, fats and oil to glycerol and fatty acid. Is it a chemical change or physical change?
Physical.
If something breaks down to different substances, what is that?
Oh, that would be chemical.
Yeah, that's
It
what the
it changes
definition of,
to
yeah.
something different. Yeah.
Any cooking or digesting food, burning are chemical reactions.
Okay.
Therefore, baking of a chocolate cake is what?
Chemical.
Because there are stuff that form after baking is different from what you ingredients
Right.
you start.
It changes. Right. Okay. I'm getting it.
Explosion of fireworks.
Explosion of fireworks. Yeah, it would be chemical because you got one thing and
Yeah,
it it goes into something else. So it's explosion and the smoke.
yeah. It's different chemicals are produced.
Mm-hmm.
So what is not a chemical change here?
Which of these is not a chemical change? The cutting of the plywood.
Okay, exactly. You got the answer.
Mm-hmm.
Which of the following is a characteristic feature of a matter? Matter has indefinite mass and definite volume.
Which of the following is
It has definite mass and definite volume, right? Therefore, first one is false. One of the
Right.
n phrases are wrong.
Right.
One is correct.
So B is correct.
Matter has definite mass, but does not occupy space. That means that one is wrong. Therefore, it's totally truth statement is false. Second one.
So both false, A and B?
Yeah.
Okay.
In the logic, when you have two phrases connected by and or but, normally both has to be correct for truth value to be equal to be truth.
Okay.
So both have one, they are similar to and clauses.
Mm-hmm.
One is correct, one is wrong.
Okay.
Matter has definite mass and occupies space. That's a truth statement. Both and clauses are true. Correct.
Correct.
Then the truth value is true. Matter has indefinite mass and indefinite volume. Both are wrong here. Therefore, it's false. Did you get the logic?
Mm-hmm.
What is the correct answer?
Matter has indefinite mass and indefinite volume.
Matter has definite mass and definite volume. It's same as occupied space.
So which one is true, D?
D, both are wrong. Indefinite mass and indefinite.
Oh, okay. So matter has definite mass, but does not occupy space. So is B right?
It has definite mass, but it has a space. The second clause is wrong in the B.
Okay. Matter has definite mass and occupies space.
Which one is true out of those four?
Let's see. Matter has definite mass but doesn't occupy space. Is it B?
Okay.
I'm not sure. I can barely see them. I gotta scroll
What
in.
exactly B statement is about? Matter has definite mass, but there's no space.
Right.
Is it true or false? B.
Yes, I think it's true.
Matter is something that has a take up the space.
Right. It doesn't take up space, right?
Does not, it does take up space.
Oh, it does. Okay.
It says it doesn't.
Right. So the one that's true is C. Matter has definite mass and occupies space.
Yeah.
Okay.
It took a while for that to figure out. Huh?
Yes. For when I can't see it, I'm not gonna get back on my cell phone because I gotta like scroll it in and then pop back over, jump back over, and I can't see it that good. I'm gonna do it on my computer the next session.
Okay, which of the following represent a physical change?
Okay, let me see. Let me try to go back and so I can see it. Which of the following represents a physical change?
Physical change is, there's no change in the substance.
Okay, let's see. Boiling water is no physical change.
Are you saying
Oh,
boiling?
let's see. It represent. Okay, so the question is, which of the following represents a physical change? Okay, let me see. We know decomposition is gonna of a dead organism. That's definitely gonna represent a physical change. Boiling of water and decomposition, neither boiling of water or decomposition. So B, is that right?
Decomposition of an organism, when somebody dies, decompose means it breaks up the matter.
Mm-hmm.
It's a chemical change.
Oh, because it changes. That's right. Let me see. What's the right answer on this then? Um, so neither boiling water or decomposition is a physical change. They're both chemical change, correct?
Boiling water is a physical change. When you boil water, it goes from liquid to a gas.
That's right. Okay. So boiling of water.
It's a physical change.
Okay.
That's the answer.
Okay.
You have to kind of read it carefully and analyze.
Okay.
Which of the following represent a physical change? Burning of fuel oil is a physical
Okay.
change or chemical change?
Um, boiling of fuel. That would be chemical.
Correct. Melting of ice.
That'll be physical because it's it's gonna be hard, and then when it melts, it's gonna be a liquid.
Or same material. It didn't change the substance, right?
Mm-hmm.
Okay,
Yes.
that should be the correct answer. When you have a correct answer, you hold on to that and check others. Both burning of fuel oil and melting ice.
Okay. So the answer is C.
You are not thinking right. That's a
Let's see.
clause and clause. One statement is true. Burning fuel oil is not a chemical change. It's a chemical change. And melting ice is physical change. When you have an and clause, both has to be correct to be true.
Okay.
So therefore, C is not the correct answer.
So is B just the melting of the ice?
You already said that it's a physical change, right?
Mm-hmm. Yes.
You are sometimes doubting your own answers later.
I know. I know. I do that a lot.
Okay, neither burning or melting is a physical change. That means, but that contradicts fuel oil burning is chemical change, right?
Right.
So when you have a O, in logic it is an O. If you have and clauses, both has to be true. One of them has to be true. But there's a
Okay.
neither. Neither is negating, right?
Right.
Therefore, last statement is not true.
Okay.
When you have neither clause, it says one of them is false
It's
means,
neither, yeah, neither a fuel or Milton and life.
yeah. So answer is B.
Mm-hmm. And I just second guessed myself, and I knew that answer from the start.
Yeah, you go for clear answer. Which of the following is a characteristic feature of matter? I let you handle this. Oh, we already done that.
Mm-hmm.
We didn't talk about scientific method yet.
No, we didn't talk about that.
So we're going to go into chemistry and discuss little more about it. Chemistry is studying matter and its changes. Matter could be classified into so many things. Elements, compounds. Elements have one kind of atom. Compounds have two or more elements, combination. Matter is defined as anything that has mass and takes up a space. How many of you know what is the difference between chemical change and a physical change? Chemical change and a physical change. Are you guys here?
Yes, sir.
Okay, you don't know the difference, right?
No, sir.
Okay, when a matter changes chemically, chemical change, matter undergoes the chemical change, the substance of the matter change. For example, burning propane with oxygen, combustion, it produces carbon dioxide and water. The carbon dioxide and water is two different substances. Chemical change is a change in substances from reactive material to the products. They are totally different. In a physical change, it's only change in the state. Physical change is a melting. Water, as an example, water, H2O. Ice melts. When ice melts, solid become ice, solid water is called ice change to liquid. So the substance never change. Do you get the idea now? Basic difference between a chemical change and a physical change.
Yes, sir.
Great. Hang on to that idea. Okay, it's a very important idea. Now we're going to talk about the scientific method. Observation is the first step in the scientific method. When you see something has changed, you are curious about it. You try to look at the change. Observation is a change in something, some color change, some noise, some temperature change, some explosion, etc. So you look into the observation and try to see a pattern in the observation. A pattern in the observation is called a law. For example, if you take a gas, if you increase the temperature of a gas, volume increase. That's the pattern. When pressure, temperature increase, volume increase. That's led to the theory, hypothesis. That gases are made out of particles. Kinetic molecular theory for gases. That's the theory we came up with. Now, theories are tested through the experiments and loop back to the theory again, changes the theory. So theory become a full-blown theory and very useful in our sciences. There are theories in chemistry like atomic theory, kinetic molecular theory of gases, kinetic molecular theory of matter, gases, liquid, solids. There are many laws. Gases follow so many laws. Charles' law, Boyle's law, Avogadro's law, Gay-Lussac's law. We're going to talk about them. These came out of observations and theories produced. Do you understand what I'm talking about? Any observation could be followed by looking at the pattern in the observation and coming up with a hypothesis, which hypothesis is a first theory, trial theory. Then it undergoes further experimentation. It becomes a well-known theory. It's proven again and again, and it becomes established. So let's look at some of the ideas behind this. Where does facts fit in the scientific method? Facts are coming out of observations. Measurements are observations. Observation is a fact. And also measurements are facts. And what is a hypothesis is called in scientific method? It's a trial theory or proposed initially without actual proof that is useful in explaining laws of observations, measurements follow laws. So hypothesis explains the laws that are created through observation. Theory is a formulation similar to hypothesis, but it is verified to some extent. It's been known for a long time. Hypothesis became a theory. But the theory is never permanent. Theories will be replaced by other theories. So you have to understand Newton's law for motion of objects, planets, stars. It's replaced by Einstein theory of relativity. That includes small particles as well, electrons and protons. You guys okay?
Yes, sir.
Okay. Do you have any questions?
No.
Okay, I'm going to go through this quickly. Measurements are two types. Measurements come from observation. First kind is qualitative. Second kind is quantitative. Qualitative is a verbal description of observation. That car moves faster than the first car moves faster than the second car. Object weighs more than the first object, weighs more than the second object. There's no number. The color changed from yellow to green. So there's no number associated. That's a qualitative measurement. Qualitative measurements are not very important in sciences. It's the initial observation. That followed by quantitative. Quantitative is you measure exactly what that change is. Change in mass, change in color with wavelength, where each color has a wavelength, so you can measure. So do you understand the difference between qualitative and quantitative now measurement? Quantitative measurement has a number and a unit. We were talking about it. So there are basic units for observations. There are three main length, volume, and mass. So metric unit system uses meters, kilograms, and Kelvin temperature. Temperature is also a unit, one of the basic units. Now you have to know how to convert units. We are going to talk about that as we go along. Now, as I said before, measurement has a number and a unit part. We're going to look at number part. Measurements are expressed in normal or scientific notation form, scientific form. Scientific form has exponents of 10. Small numbers have negative exponents. Large numbers have, scientific notation have positive exponent to the 10 positive exponent. How many of you seen this, done this before? Normal number change to scientific number. Have you done that before?
No, sir.
Okay, there are 7. Length is indicated, unit is meters, indicated by small m. Volume is liters in metric system. Mass is grams. Time is seconds. Temperature is Kelvin. The amount of substance is measured in mole. Amount of substance is the one that we use in chemistry. How many base units are there in the metric system? 7. So these base units, like meters, could be expressed in terms of kilometers, micrometers, depending on the exponent we use. What is a gigameter? GM, capital D, small, big GM, small m. That is 10 to the 9 meters, 10 to the 9 meters. big M, small m, m big, small m is 10 to the 9, 10 to the 6 meters. So these prefixes are used for temperature, uh, for mass, for seconds, various other things. Mainly milliliters also we use this. Volume also we use for volume. So how many of you seen this before? Have you guys seen it?
Yes, I have.
Okay. Now there are questions about how many meters are in kilometer. Can you answer that? How many meters are in a kilometer? Did you see kilometers is 10 to the 3? That means 1,000. 1 kilometer is 1,000 meters. How many of you are athlete here? What is a 1 mile in kilometers? It's roughly about 1,500 meters. When you run 1,500 meters, it's close to 1 mile. Okay, just study this table when you have problems, how to convert prefixes, unit prefixes. Now we're going to go back to number part in the measurement. We're going to look into significant figures in the measurement. For example, if you have a measurement 233.1, how many significant digits are there? How do you get that? A measurement is an example of a measurement is 233.1. The last digit to the right, that's 1, is called the last digit to the right is called uncertain digit. Including you start counting from the uncertain digit 1, 2, 3, 4. Therefore, 4 digits, significant figure is 4. For example, 2.3 has 2 significant digits. Do you see now how do you say significant figures in the number part of the measurement? When there's zeros, leading zeros are not significant. The leading zeros, you see that 0.0055 are leading zeros. You begin with the zeros until you hit another number. Those 3 zeros are not significant. Leading zeros are not significant. Zeros in the trailing zeros are not significant. What is a trailing zeros before decimal place? Okay, if you take, for example, let me take example, 4,000, 4000. That 3 zeros in 4,000 are trailing zeros in a whole number. There's no decimal point. Trailing zeros in a whole number. Those 3 numbers, zeros, are not significant. Therefore, significant figure is 1. Okay? This is different when you have decimal point. Zeros after decimal point are significant. Zeros are significant. For example, 3.00 liters have 3 significant digits. Because these two zeros are trailing zeros in after decimal place. This is interesting. The second problem here in the same category, 0.0450, 0.0450. That the first two are leading zeros, they're not significant. Last one is a trailing zero, therefore it is significant. Therefore 0, 5, and 4 counted to 3 significant digits. How many of you getting this? Are you guys? How do you tell significant figures in a number that appear in the measurement? Okay, these are about the rules. The fourth description, fourth item, paragraph here. Zeros at the end of the number that has no decimal points may or may not be significant. For example, $36,000 is ambiguous. If you put that's only have 2 significant digits. Uncertain digits is 6 in 36,000, first number. The 36,000 has 2 decimal places. Now all zeros are significant. Now, since zeros appear after decimal place. So all 5 are significant, including 2. There are 7 significant figures in 36,000.00. 500 milliliters. There's a trailing zeros and whole number, therefore is only 1 significant figure. But if you want to make all numbers count, uncertainty is in the last number here, last 0 to the right, you put a decimal place. Then it contains 4 significant figures. We're going to look into more problems like that, okay?
Yes, sir.
One. We also talked about how to express measurements in scientific notation, exponential notation. So you should be able to do that. If you are not sure about it, go through the Zoom meeting 1 and go through the examples I have given. Scientific notation. I go over the examples. No need to repeat the Zoom meeting 1. Now, significant figure is a number that we assign to a measurement. For example, do you see, let me go through this. Significant figure, this is important. Significant figure is how many numbers we think are significant in the measurement. Normally, non-zero digits are always significant. For example, this number 65.2 How many significant digits are there? How many digits are there? 3. Normally, 3 is the answer. When you do a measurement, we don't give a lot of numbers. We round it off to the first decimal place. So significant figure is easy to find out. This number 65.2 has 3 significant digits. This number has how many? 6 significant digits. Zeros does not count as a significant figure when it occurs. Zeros are not counted as significant figure at the beginning of a number. For example, 0.00245. There are 3 zeros at the beginning of the number. They don't count. That means leading zeros are not significant. So those zeros doesn't count. Therefore, significant figure on the measurement is 3. This one, what do you think? It should be 1. Beginning zeros doesn't count. Leading zeros doesn't count. Now this is trailing zeros. Trailing zeros at the end of the number on the whole number doesn't count. 2,570, that 0 doesn't count. 3. Now what do you think? Same argument. This should be 2 zeros on the left shouldn't be counted. Therefore, it's 5 significant digits. Now, you got the idea. I gone over this on the up to second Zoom meeting. Now I am going to continue from that. When you add 2 measurements, the answer also has a significant digit. How you get that is based on either if you're doing addition and subtraction, rules are different. If you're doing multiplication and subtraction, rules are different. For addition and subtraction, rules are you find the decimal place, lowest decimal place. Lowest decimal place in these 2 numbers are first decimal place in 3.6. Highest decimal place is 10.11, second decimal place. So first decimal place is the one that added or subtracted numbers should be rounded off. When you do a calculation, you get, when you put that in the calculator and get the answer, you get 6.51. Now this number need to be rounded off to first decimal place. So you go there, drop the 1 in the second decimal place. If the second decimal place was greater than 5, you need to add 1 to first decimal place. In this case, it's less than 1 is less than 5. So answer must be 1 decimal place, rounded off. So answer is 6.5. So this number has 2 significant digits. That's how you get the addition and subtraction significant figure. when you have three numbers added up, 5.63 plus 2.302 plus 3.16. When you put that in the calculator, when you added them up, you get 11.092. So what we said was, calculator answer should be rounded off to lowest decimal place of numbers. The lowest decimal place is second decimal place. 5.63 is to the second decimal place, 3.16 also second. So this number, calculated number, 11.092 should be rounded off to second decimal place. When you round off to the second decimal place, the number to the left is less than 5. Therefore, you just drop it. So answer is C. You drop the 2 and leave it here. This is the answer. So same idea. I'm going to go through this one only. When you add it up, you get 10.884. The lowest decimal place is second decimal place out of all these three numbers. Therefore, it should be rounded off to second decimal place. And you need to drop the 4. 4 is less than 5, so you just drop it. So answer is 10.88, which is C. So it's pretty simple. Same idea, you added problem 57. You added these two numbers, first numbers, and subtracted third number. You can do it in the calculator. So calculated answer is 4.84. It should be rounded off the first decimal place. It should be 4.8. A is the 4.8 is D. Now, it's pretty simple to get the correct answer to calculated answers from measurement. Now, multiplication and division follows different rules. These two numbers are divided. Now you don't look at the decimal places. You look at, for multiplication and division, you look at significant digit, 4 here. 5.5 has 2 significant digits. So answer should have 2 significant digits. Now we are looking at the lowest significant digit, not the lowest decimal place in addition and subtraction. So answer is 63, calculated answer. When you put that in the calculator, you get 63.854545. Now you have to round it off to 3. This is the last number to keep. If you round it off to 63, this has 2 significant digits. Now the number next to 3 is 8. Therefore, you have to add 1 to the 60. 1 to the number 3. So I describe here in detail. Answer becomes 64 when you round it off to the first place. 64 is the answer. So these are the rules that we followed. If the first digit to be dropped is between 0 and 4, drop it and all remaining digits. You drop, including 4 and all the digits to the left. Between 5 and 9, you round up last digit to be retained by adding 1. In this case, 3 is the retained number. So since this is greater than 5, you add a 1 to there. So these are the questions. The calculated answer for this multiplication is 38.5658. So first number, 4.238, has 4 significant digits. And now 9.12. Therefore, this number need to be rounded off to give 2 significant digits. Since to get 2 significant digits, you have to drop these numbers. The number to the left is 5. It's greater than 5 or greater than 5. Therefore, you need to add a 1 to the 8. Answer becomes 39. The answer is D. So multiplication and division follows significant figures, not the decimal places, lowest decimal place. So this is similar question. This number need to be rounded off to 3 significant digits. How do you get 3 significant figures from 4.2375? You have to round it off to that 23. Rounded off to 3 here. So this is 7. 7 is greater than 5. Therefore, you add a 1 to here. So answer becomes D. So that's pretty simple how you calculate significant digit in measurement. Now measurements have a number and the unit. So we looked at the unit. We are going to look at the unit part of the number. We talked about the number part in the previous slides. The units are used as conversion factors to convert one measurement to another measurement in different units. Conversion factor is a factor that converts one unit to another. Conversion factors are usually written as equalities. So this is 2.1 pound is equal to 1 kilogram. You probably heard about this. 1 kilogram is 2.21 pound. You guys have any questions? So this is a conversion factor. It could be written as equality or fractions. 2.1 pound divided by 1 kilogram or inverse. So this conversion factor here going to be one of these depending on the quantity, units of the quantity to be converted. Factor label method are used for conversion factor to convert quantity in one unit to a quantity in another unit. Units are treated like numbers. Measurements has a number and the unit. Unit also could be treated as numbers. Make sure all unwanted units cancel when you do that. For example, how do you convert 130 pound to kilogram? You write down the 130 and use the conversion factor in a proper form. The conversion factor should have pounds at the bottom of it. So one fraction has pounds in the bottom is this one. That's the one conversion factor we going to use to convert 130 pounds to kilograms. So this is the one we use because these pounds cancel out, not that one. Answer has two significant digits because the number of the significant figure in the measurement we started with has two significant digits. Therefore, this should be rounded off to two significant digits as well. Now remember, these 2.21 and 1 are exact numbers. They are coming from definitions about the conventions. They don't have uncertainty like measurements. Therefore, they are not counted in the figuring out of significant digits in the calculated number. The bottom conversion factor has the original unit in the denominator, pounds. The unwanted units, pound cancels out here and leave the kilogram. Mass and the amount of matter is measured in mass. And weight is also another name we use for amount of matter. Mass is independent of location. Weight depends on the gravity of the location. Gravity is based on spring balances. Anything that uses spring or gravity to measure the mass. So it's called weight. Therefore, mass is the one we use in sciences. Weight depends on the location, depend on the force of gravity at the particular location. Now we're going to talk about unit prefixes. We use unit prefixes. Unit prefixes are letters that G, big M, kilometers, megameters, gigameters, decimeters, to make units larger and smaller. We use exponent value. You start with the bigger units here, 10 to the 9, and go down as the prefixes become pico. That's the smallest meters if you are measuring length. Gigameter is much larger than picometer. So you need to remember these numbers. Milli is 10 to the negative 3. Micro is 10 to the negative 6. Nano is 10 to the negative 9. Pico is 10 to the negative 12. Which matrix prefixes, metric prefixes, commonly abbreviated using a Greek letter? The one using Greek letter is the micro. You go back and look at it. All except micro are big letters or alphabetical letters. So answer is micro. Use mu. Which of the following is correct order of length? Greater to the smaller. C is the correct answer. Kilometers are bigger than centimeters. Centimeters are bigger than millimeters. Millimeters are bigger than micrometers. Therefore, answer is C. Which of the following is the correct order of length? Now, decreasing these are in the problem 68. They were decreasing masses. In here, these are increasing masses. So you have to find out increasing masses are on the left side. You have to have the bigger mass. So C is the correct answer. Meter is greater than centimeter. Centimeter is greater than micrometer. Micrometer is greater than nanometer. How many millimeters are there in 1 megameter? I'm going to show you how to do this in the next slide. So you write down 1 megameter. You need to convert 1 megameter to millimeters. 1 megameter is 10 to the 6 meters. You use the conversion factor. Convert to meters. Then meters converted to millimeters. Here. 1 meter has 10 to the 3. 1 times 10 to the 3. There's a 1 missing here. So answer become 1.9. Now you have to line up like this. It's very difficult to just guess without writing down. So you get the answer always. You start with the millimeter, one need to be converted 1 megameter, then go to the meters and meters to millimeters. And the second one, how many are in 1 millimeter? So you start with 1 millimeter, convert it to the meter. 1 millimeter, 10 to the negative 3 meters. And meters converted to megameters. So 10 to the negative 9. So you get the answer. So this is pretty simple if you follow the procedure. Factor label method using conversion factor. Convert one quantity to quantity in another unit. So we done this. We converted 130 pounds to kilograms. There are a lot of conversion factors. You cannot remember all of them, but common conversion factors like 1 foot is 12 inches, 1 yard is 3 foot, 1 mile is 5,280 feet, Those are common since we use it often, we remember. 1 ton is 2,000 pounds. 1 pound is 16 ounces. That's very common. So metric relationships are the ones which we are not familiar. When you have a conversion to be done, we need to give you the conversion factor. So you can use it in the calculation. You cannot remember most of it. So we will be giving you the conversion factors. Converting pound to grams is one, this conversion factor. 1 pound is 453.6. Convert 381 grams to pounds. So you line up the calculation based on factor label method. This is called the factor label method. You do the calculation for the number, and we also cancel out the units, and then grams is converted to pounds, just like pounds are converted to kilogram. Now grams are converted to pounds. How you convert 1.844 gallons to milliliters? So you need to know how many gallons are in milliliter or conversion factor. So this is the conversion factor. 1 gallon is 3.785 liters. You convert gallons to liters, then liters to milliliters. So question is how many milliliters? So 1 liter is 1,000 milliliters. Now these conversion factors, numbers in them are exact numbers. Exact numbers are one that don't have any uncertainty. They are coming from definition. Therefore, this is the one used to get the significant digit. There are 4 significant digits. That's decimal place after this 0, make this 0 also significant. 4 significant digits, 4 significant digits here. So we're going to do some calculations. I'm going to go to the I'm going to do a couple of them. What is the metric length of 200-yard dash? Metric length is meters. So how do you convert 200 yards to meters? You start with 200 yards. 200 yards convert to feet. Feet converted to inches. Inches converted to centimeters. Centimeters converted to meters. Then you do the calculation and end up with the correct unit meters, and the number part is calculated. To get the number part, you would multiply these 4 numbers and divide it by every time with this. You don't divide by 1, but you have to, these are all ones. Once you multiply those 4, you get 182. Since this number 200 yard is 3 significant digits, because it's significant, the number answer in meters also has 3 significant digits. Now in this here, 200-meter run in a long distance, 200 2000 meter, 2000 meter here, converted to feet. So how do you convert it meters to feet? Meters to inches. This is given here, meters to inches, conversion factor. 1 meter is 39.37. Then inches, to 12 inches in a feet. So you get 651. Not 65 rounded out to 6.5, 10 to the 4. This is significant digits are 2 because you started with 200 meters. Anyway, that's how you get it. How you convert 250 yards to meters, length in meters. So you line up yards, convert that to feet, feet to meters, you get the answer. So factor label method is used to calculate certain unit to another. Start on that one next time.